According to my clock, it's the top of the hour, so we're going to go ahead and get started. For today's edition of Green Builder Media's Impact Series, Game Changers in Sustainability. Now, June is Fireworks Safety Month. However, we're going to talk about something much safer, fire sprinklers. And to do that, we have a rare treat for this edition of the Impact Series. We have two guests. That's right. Today's presentation features both Ben Ditch and Gary Keith. I'll introduce them in just a moment, but first, today's webinar would not be possible without the support of our generous sponsors. And our sponsors are BASF. BASF is a leader in the construction industry. With more than 600 products serving 75 construction product categories, BASF offers the broadest portfolio of products used directly on construction sites or integrated into other products to improve the performance of construction projects. BASF is also a global leader in sustainability and corporate social responsibility, committed to constant improvements in safety, protection of health, and environmental conservation. Bio-based insulation. Bio-based insulation spray polyurethane products help to lessen the environmental impact of residential and commercial structures by sealing and insulating in one step. Bio-based insulation integrates rapidly renewable ingredients as replacement for a portion of the petroleum in many of their insulation products without hindering performance, and they've replaced chemical blowing agents with water. DuPont. DuPont puts science to work by creating sustainable solutions essential to a better, safer, healthier life for people everywhere. DuPont is focused on dynamic science that generates real-world solutions. That's why DuPont is at the forefront of building science, with brands you depend on, like Tyvek, Sentry Glass, Corian Solid Surfaces, Zodiac Quartz Surfaces, and Kevlar. And the Green Builder Coalition. The Green Builder Coalition proudly announces a new membership level for just $50. For more information on this affordable resource, look for our next newsletter or email info@greenbuildercoalition.org. I'm Mike Collignan, Executive Director of the Green Builder Coalition, and I'll be your moderator for today's webinar. I hope that during the course of today's presentation, you'll submit questions for our guests. To do so, simply use the small box at the bottom of the Q&A. I'll review those questions and pose them to Ben and Gary during the Q&A time set aside near the end of the webcast. Now to introduce today's speakers. Ben Ditch is a Senior Research Engineer at FM Global and has an MS in Fire Protection Engineering from Worcester Polytechnic Institute in Worcester, Massachusetts. He has 13 years of experience in fire hazard analysis and specialty fire protection system design. Ben is responsible for the development and implementation of large-scale testing, including specialty hazards such as ignitable liquids, non-standard storage, and new technologies. Gary Keith is Vice President of Engineering Standards at FM Global. He's responsible for managing the development of FM Global's property loss prevention data sheets. Gary's a member of the Home Fire Sprinkler Coalition Board of Directors, and prior to joining FM Global, he served as Vice President of Field Operations at the National Fire Protection Association. Our host is the widely recognized Ron Jones, President of Green Builder Media and Board Chairman and co-founder of the Green Builder Coalition. Have at it, my friend.
Thank you, Mike, and thank you everyone for joining us today. It's pretty exciting to have experts at this level in any field, but especially in a subject area that's becoming more and more important to the industry and to our country at large. If we look at all of the dramatic events that are taking place and we think about life, health, and safety, and the impact on the environment, which we're about to learn a great deal about. So at this point, without further ado, I'm going to welcome our guests to enlighten us on the environmental impacts of home fire sprinklers. Gentlemen?
Hi, Ron. It's Gary Keith. I'm going to start it off, give a little bit of a background of the Home Fire Sprinkler Coalition and the genesis of this project, and then let Ben take us through the report. The The Home Fire Sprinkler Coalition was formed in 1996. It is a nonprofit 501c3 charitable organization strictly devoted to developing educational resources. Some of the audience may be familiar with everything that's been going on in the regulatory front on home fire sprinklers, and while the Home Fire Sprinkler Coalition material may be used as part of that, HFSC as an entity does not participate in those efforts. It's strictly to develop educational resources. The mission is to increase the awareness on the benefits of residential sprinklers, and the focus is strictly on new construction of 1- and 2-family dwellings. And we'll see in a minute why that focus is. We get questions about retrofit, and obviously people can retrofit. I've retrofitted my own home, but our focus is on new construction, basically trying to convince people that it's the right thing to do. Here's a list of the HFSC Board of Directors. I won't read through all those organizations, but as you can see, it's a wide range of public safety organizations, insurance, testing, and representation at the federal level with the U.S. Fire Administration. So a wide group of interested organizations in this issue. HomeFireSprinkler.org is the main clearinghouse for all the information that HFSC develops, and if the audience hasn't taken the time to visit that website, I strongly encourage them to do so after the presentation and make use of a wide range of information that's been collected since HFSC has been in existence. I mentioned why the focus on 1- and 2-family dwellings, and I generally don't want to let any presentation pass without sharing this information. This data comes from NFPA, and it's a couple of years old now. This was the numbers, right around the time or shortly thereafter when the study was completed. But the numbers really don't change very much every year, and I guess that's unfortunate. And the first slide here, I like to present this in two parts. The first slide is looking at the total U.S. residential fire problem. And for the purposes of these numbers, residential basically means any place where somebody puts their head on a pillow at night to describing residential. So this is looking at residential as a percentage of all fire losses in all these categories. So as you can see, we have a fire about every 84 seconds, and all those percentages are pretty significant in terms of the total fire problem. 86% of fire deaths, 77% of injuries, 72% of structural fire property damage, and one we don't often think enough about. On a percentage basis, we have 53% of the fireground firefighter deaths occurring in or on the fireground of residential properties. But really, if we want to look at where the true residential fire problem is, we really want to break out 1- and 2-family from this. So the next slide takes residential and takes it from the numerator and puts it on the denominator. So let's break out as a percentage of residential 1- and 2-family dwellings. And again, you can see the numbers there. Every one of those percentage categories are the largest in their category. And as I said, these numbers are probably 2 years old now, but they don't change much every year. So really, when you boil everything down to it, in all these categories, deaths, injuries, fire property damage, and fireground firefighter deaths, 1- and 2-family dwellings are the fire problem in this country. And the reason is, if you look at the history of the codes, and particularly sprinkler thresholds in codes, while sprinklers initially were developed as a property protection feature, the life safety benefits quickly shine through. And every time we've taken a new slice for new construction and introduced a sprinkler threshold, we've generally improved, I won't use the word solve, but significantly improved the loss results once that provision has taken effect. Like any good organization, particularly a nonprofit, HFSC developed a strategic plan, has been operating from a strategic plan that's continuously updated. And several years ago, the HFSC board really felt that the issue of environmental benefits was one that we wanted to look at. And we all sat around the table and theorized that we would see positive results on the benefits, environmental benefits of residential sprinklers, but we had no way to prove that. and FM Global. And admittedly, I was not on the FM Global staff at the time. I was on the NFK staff at the time, and FM Global stepped up to the plate and offered at their cost to provide all the resources necessary to do the testing that Ben is going to describe. So we really had a need for data more than just the theories that we were trying to present as a board. We made some assumptions along the way that we would see the type of results that we did end up seeing in areas like water quality, water usage, and other effects on the environment. And this, to us, was just another piece of strong educational input as public policy gets developed. All the advocates for sprinklers focus, as they should, on the attention on the improvements on fire deaths and injuries and property protection, similar to the issues that I described in the fire loss slides. But this was one we really didn't think that the public at large or even the regulated community had thought much about. And we think it's an important concept, and hopefully the audience will think the same way as they see the results of this report that we're going to present. So with that, I'll turn it over to Ben, and he'll walk through the background and how the report, how the study was put together, and then give you the results.
Okay, thank you, Gary. For years now, we've known that sprinklers save lives and protect property. As a result of this project, we also have scientific data to prove that sprinklers also protect the environment. We prove this by quantifying that in the event of a fire, using sprinklers will reduce three things. The first is pollution, and that's in terms of both air and water. The second is water usage, and the third is fire damage. So why now? I think Gary gave us a nice lead-in and some of the background as to where we're at and what some of the impetus is for this type of project. But I'd like to add that local communities are grappling with new green legislation, which in some cases means water use restrictions. In other cases, it's building to sustainable building practices. And recently, there's been the initiative by the National Fire Protection Association in the U.S. to mandate that sprinklers be installed in all newly constructed 1- and 2-family homes. These concerns and initiatives are not limited to the U.S., and there's a growing global concern over sustainability. So in that light, FM Global conducted 2 research projects in 2009 and 2010 to develop hard data to help dispel the myths around using sprinklers and to quantify some of the claims being made about the use of sprinklers. And this presentation will basically give a snapshot of those 2 projects. Now, the first one examined the impact of risk factors such as natural disasters or fire have on the total life cycle carbon emissions of a building. And the second study looked at quantifying the environmental impact of using sprinklers. Typically, when a life cycle carbon emission analysis is conducted, the analysis includes 3 things. The carbon associated with the construction of the building, with the normal operation of the building, and with decommissioning of the building. And you can see that on the graph shown on this slide. Our study took this one step further and looked at the impact of risk factors, such as a fire would have on the total carbon emissions. Now, how we did that is detailed very well in the report that we have available. But I'd like to just show a quick overview of that process. We first have to account for the carbon released during the fire itself, and also the embodied carbon associated with the materials needed for construction. But understanding that not every building experiences a loss, we also had to account for the frequency of fires. Therefore, the analysis needs to be conducted for each type of occupancy. Furthermore, not every fire will result in 100% loss. So the severity of the fire is taken into account by both the damage fraction and the replacement fraction terms. In the bottom left-hand corner of this slide, you can see all the different terms that we accounted for. For all this analysis, we used published data, our internal loss history, and data from other insurance companies. Using this methodology, we looked at 4 different scenarios. An office building built to typical building standards, an office building with reduced operating emissions, in other words, a green building, a high hazard occupancy, such as a chemical plant, where the frequency of fires is greater and the severity of those fires is greater, and finally, a residential home. So let's start by looking at buildings constructed with typical building standards. That would be case 1, 3, and 4 from the previous slide. Our work showed that a fire in an unsprinkled building could increase the total carbon emissions between 0.5 and 14%. If proper risk management techniques are employed, for example, sprinklers, this contribution can be reduced to less than 0.4% for all cases. Now, if we look at a green building, the impact is significantly greater. Okay, again, we have our standard construction shown as the yellow curve. And adding on top of that, we have the carbon emissions associated with green construction. Now, the first interesting thing here is the carbon emissions during the construction phase for a green building are slightly greater than a standard construction. But then over the operation of the building, you start to see the gains from that green construction. Now, a fire in an unsprinkled sustainable building can triple the total carbon emissions, thus negating the benefits of building the green building in the first place. This study shows that if you're doing a sustainability analysis or a sustainable building design and do not take into account risk factors such as fire or flood, wind, or earthquake, and the measures needed to mitigate them, then you don't really have a sustainable design. To quantify the environmental benefit of sprinklers, we built 2 full-size residential living rooms at our research campus and then burned them down. One room was unsprinkled and one room was sprinkled. In both tests, we had typical fire service response. We chose a residential living room setting for this study for 2 reasons. The first was to support the educational mission of the Home Fire Sprinkler Coalition. And the second was because sprinklers perform the same no matter if they're installed in a living room or in a Fortune 1000 company. Therefore, we chose a setting that everyone can relate to. Here's an overview of the room, including the furnishings. The room dimensions were 15 feet by 20 feet wide with an 8-foot high ceiling. And they were fully furnished and carpeted. And you can see the contents included bookshelves, console table, a coffee table, TV stand, various couches, and love seats. In the sprinkler test, a single residential sprinkler was also installed within the center of the room at the ceiling. You can see that here is the black dot. And for both tests, ignition occurred in a magazine rack located between the recliner and the love seat. And that can be seen in the upper right-hand corner of the schematic with the rectangle indicated as M.rack. Here we have a picture of the outside of the building. The rooms were built by an outside contractor to industry standards. The design represented a room in the corner of a single-story house with 2 exterior walls and 2 interior walls. This image is of the exterior walls. These exterior walls had 4 double-hung windows and an external door installed. And the walls and roof were insulated like a typical home in the Northeast, with meaning they have glass insulation. This is a picture of the interior walls. The interior walls consisted of a solid wall and a wall with an open archway, representing an opening to a hallway or another room in the house. The interior walls were not insulated. Here you can see some images of the inside of the room. Again, the rooms are fully furnished and decorated and consisted of brand new furniture. In this picture, we can see a recliner, a love seat, a couch, the TV, You can see curtains on the wall, various tables, and a lamp. Moving on to a different image of the room, you can also see the couch. You can see the carpeting well in this image. And you'll also notice in the center of the room, there's an instrumentation station that's there to measure the gas temperature and concentrations of combustion gases. And finally, we have a view looking through the archway of the room. Here you can see the bookshelf and the console table. You'll also notice another instrumentation location at the archway to measure the gas temperature and concentration of combustion gases exiting the room. The ignition source was 3 rolls of newspapers and a magazine rack. And again, that was located adjacent to the left seat. In the sprinkler test, a single FM-approved residential sprinkler was used. The sprinkler was approved for a 20-foot by 20-foot coverage area, meaning that we only needed 1 sprinkler for the size of our room. The installation was consistent with FM Global Property Loss Prevention Data Sheet 2-5, which requires a 0.1 gallon per minute per foot square density. The sprinkler characteristics were a fast response with a link rating of 155 degrees Fahrenheit, and we provided a discharge pressure of 19 psi to achieve a 0.1 density. Fire service response was initiated via smoke detector activation. The fire service took action 10 minutes after the smoke detector operated in both tests. The 10 minutes delay represented the fire service receiving the alarm, traveling to the location, and setting up the equipment. And it's based on national data. All testing was conducted at the research campus in the Large Burn Laboratory under the 20 megawatt calorimeter. Here you see an overview of our research campus in Rhode Island. And the yellow arrow points to the Large Burn Lab portion of the overall facility. And you can see that that lab is actually broken up into 3 segments. There's the north and south movable ceilings, and then in between there's a 20 megawatt calorimeter. The testing under this calorimeter allowed for measuring the heat release rate from each of the fires, capturing and analyzing all of the air emissions generated during the fires. The 20 megawatt calorimeter has a collection diameter of 36 feet. And here you can see an overview schematic of the relative location of the test room, which was offset to maximize collection of the gases. And you can see the rectangle in this room. The windows are represented with the green rectangles. The red rectangle is the open archway, and the black one is the closed door. The calorimeter duct above this space was instrumented with our standard gas analyzers for monitoring oxygen, carbon monoxide, carbon dioxide, and unburned hydrocarbon levels. We also hired an outside environmental consulting firm that duplicated our 4 measurements and analyzed the air emissions for an additional 119 species. Okay, now we'll move on to a side-by-side video of the 2 fires. Before I do that, I'd just like to describe the layout of the videos. On the left-hand side, you'll see the sprinkler test, and on the right-hand side, you'll see the unsprinklered test. The top images show the external cameras facing the wall where ignition occurs. The bottom images show the internal cameras facing the wall where ignition occurs. Okay, is my screen viewable to everybody now, or should I? Okay. Okay, I think we're sharing that screen properly now. We'll start the video. Okay, at time 0 on the clock, both fires are ignited. with just a propane torch. Again, you can see the location of the fire right next to the love seat, and is also in close proximity to the curtains. The fires develop rapidly, and you can see the flame starting to travel up the curtain. At 25 seconds, we had a photoelectric smoke detector activate in each test. So this starts the 10-minute response clock for the fire service. At 44 seconds, the sprinkler activates on the sprinkler test. You can see that on the bottom left-hand image is water droplets impinging on the lens of the internal camera. Now at this point, the fire is confined for the sprinkler test to the ignition location. However, if you look at the images on the right hand of the screen, you can see that the non-sprinklered fire test continues to grow. If you also look towards the archway on the left of the screen, you can see smoke exiting the room. Moving ahead to 3 minutes, you can now see that the sprinkler test on the left, the fire is still confined to ignition, but at 3 minutes and 10 seconds, we now have breakage of the windows on the non-sprinkler test. And as we pan out of the camera, you can start to see some of the thick black smoke exiting the building. By 4 minutes and 50 seconds, we now have flashover in the non-sprinkled room. Now that's the time when every combustible object in the room begins to burn. At this point, if more rooms are present, the fire would propagate through the rest of the house. Now this is important, particularly in light of the fact that we still have 5 minutes before the fire service will arrive. And moving on to 10 minutes and 25 seconds, fire service is now responding to these fires. In the sprinkler fire test, the fire service approaches the front door, pries it open, and fights a small fire. In the non-sprinklered fire, the fire service needs to fight the fire from a distance before being able to gain access to the room. And here we can see some post-test images. On the left-hand side, we can see that the sprinkler test has very minimal fire damage, where the non-sprinkler test is a complete loss. Okay, I'll pause the video there, and I'll stop sharing my screen. Okay, there we go. The data collected during these tests quantify the reduction of 3 things: pollution, water usage, and fire damage. First, we have a plot of the chemical heat release rate as a function of time generated during each fire. The first thing to look at is the peak heat release rate. For the known fire case, we had 13,200 kilowatts as the peak heat release rate, whereas for the sprinklered case, that was reduced to 3,000 kilowatts. Summing all the energy released during these tests, there is a significant difference in the total energy released between the non-sprinklered and the sprinklered test. Now this is important because lower heat release rates equate to less fire damage. That brings us to our first key finding. Sprinklers reduce fire damage. In the no sprinkler case, we had 100% fire damage. However, in the sprinkler test, we had less than 3% fire damage. The greater fire damage in the non-sprinkler test has a direct impact on the carbon emissions of the building or facility due to the embodied carbon associated with the building materials necessary for reconstruction and those associated with the manufacturing of furnishings and contents. now we can dig a little bit deeper into the equivalent carbon emissions. Here I'm showing a plot of the concentration of carbon dioxide and carbon monoxide measured within the 20 megawatt calorimeter duct as a function of time. The blue curves show carbon dioxide, and the pink curves show carbon monoxide. And you'll see for each pair of curves, there's data from FM Global and data from an outside contractor, APCC. There's two things to note here. First, there's excellent agreement between the data collected by FM Global and that independently collected by the outside consulting firm. So this adds credibility to our results. The second is that this data, along with measurements of other greenhouse gases, can be used to determine the equivalent amount of carbon dioxide generated in each test. Without a sprinkler, 891 pounds of carbon dioxide equivalent was generated. That's 404 kilograms. Now I'll show a similar plot for the sprinkler test. Again, we have excellent agreement in the carbon dioxide data. You'll see a slight discrepancy in the carbon monoxide data, but that's associated with the accuracy of the analyzer, since the detected levels were less than 6 ppm. So we're talking about a very small amount. In total, with the sprinkler installed in the room, we were reduced to 19 pounds of carbon dioxide equivalent generated during the test. And that brings us to our second major finding. In the event of a fire, using sprinklers will reduce greenhouse gases by 98%. And to our knowledge, this is the first time that that's ever been quantified. Looking at U.S. data, 2.9 million homes were constructed between 1998 and 2008. Based on the average home size during that period and NFPA statistics on the average amount of damage to the homes, we were able to calculate that if sprinklers had been used, the potential reduction in greenhouse gas emissions would be 2.2 billion pounds of carbon dioxide. Now, greenhouse gases were only a subset of the species that were measured in air emissions. In total, 123 species were monitored and measured. Of those species, 76 were detected in either the sprinklered or non-sprinklered test. In the non-sprinklered test, 24 of those species were detected in a ratio greater than 10 to 1. 11 species were detected with a ratio greater than 50 to 1, and 6 species at a ratio greater than 100 to 1. Now, moving on to water usage, this table shows the amount of fire protection water used in each test. The sprinkler test includes water from both the sprinkler and from the fire service, while the non-sprinkler test includes only water from the fire service. And you can see that the sprinkler test used approximately 500 gallons of water, where the non-sprinkler test used approximately 1,000 gallons of water. And I think it's important to put these in relevant terms. The time to extinguishment was roughly the same for both tests. So for the single room used in this study, the water usage was 50% less in the sprinkler test than in the non-sprinkler test. If the analysis is extrapolated to a full-size home, the water usage reduction could be as high as 90% due to fire spread to additional rooms in a non-sprinklered home. And I think you saw that very well in the video with the amount of flames exiting the building, exiting the windows, and also exiting the archway. This water use is important in light of the fact that many jurisdictions are imposing water use restrictions. Finally, we wanted to examine water pollution. The wastewater that was generated from both tests was collected and analyzed based on ANSI and EPA standards and compared to federal water criteria. You can see at the exit of the archway, there is a stainless steel collection bin, which was set up with pumps that went to a containment vessel to collect the water runoff. What we found was that the pH level of the water in the sprinkler test was within normal acceptable limits, having a pH of about 7.9. However, in the non-sprinkler test, the pH of the water was in excess of 12. Wastewater with a pH greater than 10 is considered to pose a serious environmental concern. We also wanted to look at other pollutants that might impact surface and groundwater sources. What we found was in the sprinkler test, total cyanide, nitrogen, phosphorus, and benzene exceeded federal water quality criteria. And in the non-sprinkler test, we found that in addition to the high pH level, 6 constituents exceeded federal water quality criteria, including total dissolved solids, total cyanide, nitrogen, phosphorus, antimony, and arsenic. These results show that in the event of a fire, sprinklers will also reduce water pollution. So our data shows that in the event of a fire, sprinklers reduce 3 things: pollution, including both air and water, water usage, and fire damage. As I said at the beginning of this presentation, this is a very brief snapshot of 2 fairly large projects. The reports for these projects are available for free on our website at fmglobal.com/research reports. There's also a video news release detailing the study that can be found on YouTube.
Very good. Thank you.
With that, that's all we have.
Great. I have a question that's been nagging me since the very beginning, and that is, where is the accountability for these environmental impacts, or does that accountability even exist? In other words, if there is an incident and we have air and water pollution, is there any entity, including the homeowner or the community, that is held responsible for that pollution?
Ron, it's Gary. There has been cases in some industrial commercial properties where if you have a large unsprinkled or inadequately sprinkled facility that's resulted in many hours of fire service discharge from ladder streams, aerial streams, and it has resulted in some off-site pollution. There has been mediation that's gone back to building owners in those cases. I'm not aware of any such incidents on the individual local level for an individual homeowner, but who knows? Time will tell whether or not if environmental restrictions become further than what they are, you may see that type of action take place.
Well, thank you for that clarification. What about the insurance industry's role in this? How much incentive do we typically find for the home builder or the home owner, the occupant, to involve sprinklers in their planning and execution? Is there an appropriate amount of support from the insurance industry, in your opinion?
There is, and the Home Fire Sprinkler Coalition has looked at this. And again, I have to qualify my answer a little bit now that I'm wearing the FM Global hat. FM Global does not write individual homeowner insurance policies. We do have State Farm represented on the HFSC board, and we have done outreach and analysis with the residential insurance industry in general. It can be safely said that all the major national underwriters that you might think of are all providing some level of discount to the individual homeowner. We've seen ranges between roughly 5 and 15%. They do apply it differently. Sometimes they'll just apply it to the fire portion of the policy. Sometimes they'll apply it to the bottom line. Sometimes they'll do it as part of a general security package. In many cases, they want monitoring, which is not a bad idea. The standard and the local codes usually don't require monitoring, but sometimes to get the insurance discount they do. I think you have to look at it this way. The installation standard for a single home is a life safety standard. So it doesn't require sprinklers in every particular spot in that home. It doesn't require it in attic spaces, small closets, small bathrooms, basically all the occupied areas of the home. From the insurance standpoint, which is primarily underwriting the property aspect, they're basically saying that's good enough for us to provide some level of discount. 30 years ago, they weren't thinking like that. And, there are still some myths out there that say that the sprinklers are going to result in the insurance company increasing the policy because of a threat for water damage. And that is a myth. That's just not true. I think from the standpoint of the individual consumer, the advice is to shop around and don't always listen to the local agent, because many times the local agents don't represent accurately what their member companies are actually doing from an underwriting standpoint.
I see. I have one other kind of broad question, and then I want to alert Mike that we should open the forum here for questions from our audience, which I think we have several. And my question is, this is one aspect of looking at the attempts to reduce and mitigate fire damage and that sort of thing. We know that choice of exterior finishes and non-combustible materials for roofing and those kinds of attempts are also important, and that also then there are certain kinds of integrated distributed plumbing systems within the structure itself. And so my question in all of that is, how closely are you working with the other sectors, the other segments of the industry who have a role in this in order to sort of try to complete the package and help to reduce the damage and resulting pollution from residential fires as a whole?
Let me address the two specific ones. In terms of exterior threats of fire, the Home Fire Sprinkler Coalition is not active in that effort. The focus of HFSC are the issues within the dwelling. Again, those numbers that I gave you earlier are focused on incidents that occur and originate within the dwelling. So while the issue of exposure protection is certainly important, not only in wildfire areas but also in normal subdivisions, the issues that we're looking at are focused on the occupants of the individual dwellings. You were referring to integrated sprinkler plumbing systems. That is recognized. It's called by various names. Multi-purpose is kind of the common one we hear. That is recognized within the national standard, which is NFPA 13D for 1- and 2-family dwellings. So that concept is appropriate, is in play. I know there are licensing issues associated with that at the state level and sometimes the local level, but from an installation standard, it is allowed, and it is being done in many parts of the country.
And then if I may add, I actually had another thought that I wanted to express, and that is, how closely are you involved in looking at the materials and components of interior furnishings and fabrics and finishes and so on?
A lot of work has been done by UL in that area. UL is also represented on the HFSC board. They've done a project. They call it the Legacy Project. And if you go to the UL website or to the NFPA's Fire Sprinkler Initiative website, it captures in both those places a series of tests that they did to look at the furnishing and contents of today's typical modern dwelling versus a home of a couple of generations ago, and the difference in the time in fire development and the difference in time therefore the time to escape and for the fire department to respond and to deal with that incident. So there is a big difference in not only the furnishings but also in the open floor layout in a modern home compared to the relative compartmentalization that we had in homes built years and years ago.
Interesting. Well, at this point, I should let Mike introduce some questions from those who are in attendance. Mike, I think you have some.
Oh, Ron, we have a lot, and so I'm looking forward to get into this Q&A because we have a lot of questions from the audience, and I think there's a lot of good ones in here too. Given what was just given the response we just heard, I want to ask Jeff's question because you may have covered it, but I just want to make sure that his concerns addressed. Jeff wants to know how does the age of the structure or the house, and he's talking about 1- and 2-family dwellings, how does that impact the statistics? In other words, residential housing stock that was built in the 50s, the 60s, the 70s, how does that compare to the fire hazard in the housing stock that was built in the 90s or the 2000s?
Yeah, it's a common question that the coalition and the advocates get on this issue. The typical data that the fire service generates to produce a lot of these statistics doesn't capture the age of the home. However, the NFPA studies have looked to the best of their ability to look at age as an issue. And the only factor in home fires where age becomes an issue or can be singled out is on electrical systems. And if you look at the improvements in the electrical code over the years, that has made a difference in ignition scenarios in older housing. Beyond that, it's more driven by economic issues. Admittedly, you have older stock and perhaps you have occupants on a lower economic scale than new construction. But here's the bottom line. If you take that typical living room setup and you put it in a home that was built yesterday and you put it in a home that was built in the 50s, you're going to get the same fire. The threat to the occupants is the same. And it really, the typical home fire has very little to do with the construction of the dwelling. It has everything to do with the occupants and what the occupants are doing in that dwelling and what the contents are within that dwelling. So in most cases, you have a 100-year-old home, you're going to be filling it up with furniture that's much younger than that.
Okay, appreciate that. We had a question from Allison as well, and she wanted to know, unfortunately it fell off the list. It was something to the effect of, how does this data relate to the flame retardants that you'll find in upholstery, in certain building materials, and I wish it was still on the list, and I apologize now, Allison, that for some reason it's not on there at the moment, but I hope I'm conveying it at least somewhat accurately. So the question again goes back to just the flame retardant chemicals.
Right, and I know furniture flammability and retardants is an important topic, and again, from an environmental standpoint of the impact of the chemical treatments and so forth, I know many states are looking at from a regulatory standpoint. But here's the issue. The retardants are really trying to prevent ignition from a source, a small source, not necessarily an open flaming source, a small contact source, like a smoldering cigarette or something like that, placed up against the piece of furniture. What that furniture flammability standard will never do is protect against something that's already flaming. So if you have an appliance, a television, if you have a wastebasket or a roll of newspapers like in our ignition source, the furniture flammability requirements of any furniture are never going to stop that fire from developing and growing and affecting that piece of furniture as the second piece of equipment or content that's involved in the fire. So yes, while it has some impact, most likely from those small initial contacts, once you get the typical, if you will, large residential fire developing, it's not going to give you any benefit.
Okay. I had just a very quick, kind of more of a clarification question, and it goes back to the statistics that we were talking about with Jeff's and Ron's questions. You had made a comment early on in the presentation about wherever anyone puts their head down to sleep, and you were talking about residential buildings. Where do hotels and motels fall into? Do they fall into that category, or do they fall more into the commercial?
Yeah. There are certain classifications. Some of the smaller ones would fall into residential. There is some of that in there, as a residential occupancy type occupancy. But as an individual occupancy, hotel and motels have improved dramatically over the last 25 years. Once the federal guideline on federal employee travel kicked in after several high-rise hotel fires in the early 80s. For the most part, and again, the requirement there was to sprinkler them. And so once the whole hotel industry responded to that, we've seen a dramatic improvement in hotel fire safety over the last 25 years.
Okay. I appreciate the clarification because I wasn't quite sure where exactly some of those fell in. Obviously, I knew some were very small and some are quite large in size. So appreciate the clarification there. I want to go to, we've got two questions, and they're both kind of touching on the LEED program. So I'm going to kind of group them together. George wants to know, now that you have proof of the benefits associated with the installation of fire sprinklers in a home, is there going to be any attempt to petition to get a LEED credit for home design that includes sprinklers? John his question really covers the non-residential construction projects, and he wants to know if there are LEED points available for non-residential construction projects, and if not, why?
The Home Fire Sprinkler Coalition Board has talked about it a little bit ever since the study was done, but admittedly, we have not ventured into the LEED issue at all, and I really don't have the background or expertise to really speak to that. It certainly would seem to make sense. I know there have been some discussions about particularly in high-rise buildings again, about the effect of sprinklers within the LEED requirements, but I'm not aware of any specific activities in that area.
Okay. We have a question about, a couple questions about code. So the first one from Pete is, will this become code? Or do you anticipate, trying to get this into the code at some point?
Well, the simplest answer to that is it already is. The two national model codes that are out there, NFPA and ICC, International Code Council, NFPA introduced it as a mandatory provision in the 2006 editions of their model codes. ICC did the same thing with the 2009 edition of the IRC. Admittedly, the IRC is used for most residential code construction in this country. And again, that gets into the whole regulatory issues. Currently today we have two states, California and Maryland, that have passed the requirement. They've had it in effect for over a year now. And so, again, the advocates look at a state like California that's got an economy bigger than many countries and has jurisdictions from the largest urban areas to the smallest rural and everything in between. And the world hasn't ended in California. And admittedly, in both those states, they had the provision, the ability to adopt local requirements. Some states can't do that. And that led to many years of support at the local level from successful sprinkler ordinances being passed, and suddenly that got ramped up to the state level after the model code provision was introduced. And people said, yeah, it's a good idea. It's worked locally for many years. Let's do it statewide. So, I think, personally, just speaking for myself, I think we'll see that trend continue. It may take some time, but we'll get there.
Well, and I don't want to speak for Pete, but I wonder if his question was kind of more in the direction of Robert's. Robert comes at us with a much more pointed question. I think one that's probably on the minds of more than a couple attendees here. And Robert wants to know, okay, now that we can verify the sprinkler systems save lives and they substantially reduce fire damage, and now they're also, there's systems in residential dwellings that are now green, why did Pennsylvania rescind the mandatory requirement for installing fire suppression in residential homes? Now, I would think it'd be because the study and this information is relatively new in relation to when Pennsylvania made the decision. But I think this is a question that is probably on the minds of many attendees here.
Yeah, and I guess I don't feel comfortable, representing both FM Global and HFSC in the educational aspect of this session. It's very much involved in the politics that occur at the state level, and everybody probably on this call probably is aware of that there are many states that have addressed this issue or attempted to address this issue since the model code provisions were introduced, and we have seen restrictions put in place. It's amazing that of all the model code requirements that are out there, this seems to be the only one where a piece of legislation gets passed that says the promulgating body can't even consider it. So it is wrapped up in the politics, and I think that's the only thing I can say. And it just remains to be seen whether or not it can be untangled from that political aspect in the subsequent years that the code maintains the provision. I think the laboratory, if you will, that we have within Connecticut and Maryland over the next couple of code cycles, I think should be very beneficial. If they are able to show that they were successful in implementing the provision in all types of communities and saw successful lost results as a result of having that provision in play that may slowly over a period of time gain acceptance in other areas.
Well, I love that your response, it kind of went right towards this question from Sarah. And I think this may be able to give you a better chance or a way to extrapolate upon what you were just talking about. Sarah points out that unfortunately the home fire sprinklers have become a political issue in the building industry, going back to the Minnesota Code hearing. What can building professionals do to depoliticize sprinklers and use this environmental information to affect positive action in the industry, in their communities? What's your suggestion there?
Well, I think, I think just to get as much information as they can. I mean, that's what HFSC has been all about. I mean, we've been trying to tackle the myths that are out there. I mean, a common one is the fact that, people still think because of what they see on television that or in movies that every sprinkler is going to go off, similar to what they experience with interconnected smoke alarms. And this notion that smoke alarms are good enough. There's this fear that there's going to be mission creep in this area, that because we've seen an increase in the requirement of smoke alarms that in certain occupancies that we're going to see the same thing with sprinklers. Okay, the fire service and its advocates are tackling new construction now. Suddenly we're going to go back and try to get sprinklers mandated in every piece of housing stock out there, and that's just not practical. Even the strongest sprinkler advocate wouldn't agree to that. So I think it's just all about education, and the communities where it's been successful, I think would speak to that, and it's just going to take time, to build on those successes and to get a wider range of acceptance. HFSC has been participating in the International Builders Show for about 12 years now or more, and the experience that we've seen from builders coming in to visit us in the booth has changed dramatically over that period of time, and I think that's a symptom of what we're seeing, that the building industry wants the information, wants accurate information. That's what we're trying to give them, so that they can make a decision, even if they're not mandated. They can make a decision either at a minimum to offer it as an option, or in some cases we've seen several contractors decide, yeah, this is the right thing to do, and we're gonna build our housing stock with this. My local community just had a 25-home subdivision. I'm in a small town, so 25 homes may not sound a lot, but for my community it is. And because of the distance and the water supply and the distance for fire department response and the water supply in the area, the planning board through zoning, we can't pass a mandate requiring sprinklers, but the planning board did it as part of a special permit and said those 25 homes have to be sprinkled. And I know the local fire chief caught up with the developer a couple of months ago and said, how's it going? He said, no problems. He said, I'm using it as an incentive to compete against my competition in the neighboring town, and he said it's working. The consumer, very safety conscious these days, is recognizing the benefits of sprinklers, and he said, my homes in this development are selling faster than my competitors.
I know that some of our attendees may only have until the top of the hour to stick with us, but I wanted to ask both of you gentlemen, do you have a little bit of time to stay after, because we do have some more questions to get to. This has frankly been a very strong Q&A day.
Yeah, we're good.
Sure.
Okay, great. Before we do get to the top of the hour and some people that may have to leave, I did want to convey a question that came in from Maria, Joe, and Tiffany. They all want to know, how do they get a copy of this presentation, whether it be downloadable or hard copy?
My understanding that you're providing the video of the presentation as part of this.
Yes,
Already?
the webinar will be archived. It is being recorded, and it will be archived on the Green Builder Media site.
Yeah, that in combination with the video that Ben mentioned on YouTube, which shows a good portion of the video clip that we showed today, as well as the key educational points. That in combination with the full report is basically everything that you would need.
Okay. I wanted to get to a technical question, if we could. And Byron and April kind of basically asked the same question. The FM residential standard requires zero point 0.1 density, while the vast majority of homes will be sprinklered per NFPA 13D at 0.05 density. Do you think the results for the sprinklered fire would have been different with the lower density?
No, I think in the case of the test that we ran here, you're catching the fire at a very small phase in its development. We showed a peak heat release rate of 300 kilowatts, but the fire wasn't that large, and not even that large when the sprinkler operated. So it's actually able to contend with the relatively small fire source that we had at that time. I think you're probably looking at about the same results. Again, just for this scenario, the same results if you use a 0.5 or I'm sorry, 0.5 or a 0.1 density.
And Mike, and one other thing to keep in mind is that HFSC, one of the first products that HFSC produced was a study in Scottsdale. Scottsdale was one of the early adopters of residential sprinklers. So HFSC went back and looked at the 10 and the 15-year mark, Scottsdale's fire loss data. And out of all the incidents that they had, 90% of their fires, sprinkler fires, were controlled by one sprinkler. So that, I think, and that they used the NFPA 13 standard. So I think the history that we've seen out there, the real world history shows that, as Ben says, that you catch it early and it doesn't take a lot of water.
Okay. And for those that are interested, there is the link to the archive section of Green Builder Magazine's website, where you'll be able to see the recorded version of this webinar. I wanted to get to Elizabeth's question next. Have there been any studies quantifying the environmental impact of the installation of sprinklers when a fire does not occur?
Yeah, not that I'm aware of.
Okay, well that's fine. I just thought I would ask on behalf of Elizabeth there.
I guess the angle is, that it takes energy and materials to put these systems in, and they may never get used. I guess that's true, but we always do a comparison, and maybe it's overused. I don't know. Probably the opponents would say it is, about the history of automobile safety and how we started with seat belts, and the industry was opposed to that, and the other side of the coin, or the analogy to that in home safety, is smoke alarms. And initially the building industry was against that. I mean, a lot of the same arguments against sprinklers, you go back in the records, the testimony on smoke alarms, the same arguments are being used. And then the automobile industry fought airbags. And, that's sort of the comparison on sprinklers. But, how many airbags are being installed now in automobiles out of every nook and cranny in an automobile, overhead, sideways, and every direction, and how many of those will never operate? But when they do, and if it's my car, I want it to operate. And I think the same analogy can be used, and the same logic can be used with sprinklers.
I like that analogy a lot because, you can say not just seatbelts, but also airbags.
Right.
Kristen had a question. She wants to know, and you guys kind of touched on this a little bit when you were talking about one of the myths that's still out there. So I think it's probably good to address this from Kristen. What is the impact of the water? Has this been addressed? Are we saving the house from fire only to risk water and mold damage?
Well, again, looking at Ben's numbers, we're going to use a tremendous amount more water with the fire department response on an unsprinkled fire. Even if they're able to control that fire and limit it to the room of origin, the water that they're going to use from a 250 gallon per minute hose stream, and any residential fire is going to require them to use a minimum of 2 hose streams. That's going to dump a lot more water throughout that home. That's going to make that home much more susceptible to mold damage from the water in the area that spreads, the water that spreads to areas of the home that weren't involved with the fire, much more than what we're going to see with the sprinkler. My favorite line, I can't take credit for it, but my favorite line is, there's no such thing as water damage in a total fire loss.
That's a great point. Well, that exhausts our questions. I really appreciate all the questions that came in from the audience, and I hand it back to Ron now.
Well, thank you, Mike. And gentlemen, thank you very much. It's been extremely informative, and I'm delighted that we had so much participation from those in attendance as well. So again, you can access this information if you go to our website and look in the archives. And Mike, I guess you can say an adieu for us and tell us what's happening on the next Impact Series.
Sure. Yep, I wanted to take one more opportunity to thank our sponsors, which are BASF and Bio-Based Insulation, DuPont, and the Green Builder Coalition. I also wanted to thank everyone for attending today, and especially all those who asked those wonderful questions. Finally, a big thank you to Ben and Gary for taking this time to share this new data and perspective. We hope you'll join us next month for another edition of Impact Series, Game Changers in Sustainability. We're going to be back on Wednesday, July 31st at 2 p.m. Eastern with Margaret Davidson, and we'll be discussing risk reduction and prevention when it comes to extreme weather events. Hope to see you then. Take care and have a wonderful day.